Good morning, good afternoon, good evening, wherever you are, whenever watching this. Welcome to a new Tech Talk video of utilization of electrical energy subject. And my name is A. Surendra. I am pursuing BTech final year in the stream of electrical and electronics engineering. In today's session, we are going to discuss about the electric traction systems in this video. And when coming to the contents we are going to see in this video is the first one is electric traction systems and types of electric traction systems. Those are direct current electrification system and alternating current electrification system and the composite systems. Also, advantages and disadvantages of all the three types of electric traction systems. And let's get started with one by one. And the first, what is electric traction system? The system which is use electrical power for traction system, that is for railways, trams, trolleys, etc. is called electric traction. The track electrification refers to the type of source such supply system that is used while powering the electric locomotive system. It can be AC or DC or a composite supply. Selecting the type of electrification depends on the several factors like availability of the supply, type of an application area, or services like urban, suburban, and mainline services, etc. These are the systems. This is the basic definition of the electric traction systems, and these are three types. And the first one is direct current electrification system, and the second one is alternating current electrification system, and the third one is composite electric traction system. And when coming to these three types of electrification systems, direct current is operated under 300, 500, 600, 750, 1200, 1500 and 3000 volts. These are the power ratings of voltage ratings of the direct current electrification systems. And coming to the alternating current electrification system, voltage ratings 15 kV AC and 16.7 Hz, frequencies 25 kV AC and at 50 to 60 Hz of frequency. And coming to the composite system, the voltage ratings is 1.5 kV DC and 3 kV DC, 15 kV AC at 16.7 Hz and 25 kV AC at 50 Hz of the frequency ranges. And the direct current electrification system is the choice of selecting the DC electrification system encompasses many advantages such as space and weight considerations, rapid acceleration, and braking of DC electric motors, less cost compared to AC system, less energy consumption, and so on. There are many advantages as compared to the AC electrification system. In this type of system, three-phase power received from power grids is decelerated to low voltage and converted into DC by the rectifiers and power electronics converters as shown in the figure. This is the overhead line and this is the motor control. This is the motor is directly connected to the wheels of the electric traction system. And this type of DC supply is supplied to the vehicle through two different ways. Third and fourth, the rail system operate at low voltages 600 to 1200 volts, and overhead rail systems uses voltages 1500 volts to 3000 volts. And the supply systems of DC electrification include 300 to 500 volts apply for the special systems like battery systems, and 600 to 1200 volts for urban railways like tramways and light train metro trains, and the 1500 and 3000 volts suburban and machine mainline services like metros and heavy metro trains. Due to high starting torque and moderate speed control, the DC series motors are extensively employed in the DC traction system. They provide high torque at low speeds and low torque at high speeds. This will help to use in the DC electric traction system. The main advantage in this is in case of trains, heavy trains that requires frequent and rapid accelerations, DC traction motors are better choice as compared to AC motors. And DC trains consumes less energy compared to AC unit for operating same services. And the equipment in DC traction system is less costly, lighter and more efficient than AC traction system. It causes no electrical interference interference with nearby communication units. And coming to the disadvantages, expensive substations are required at frequent intervals. The overhead wire or third rail must be relatively large and heavy. Voltage goes on decreasing with increasing length. And coming to the electric alternating current electrification systems, an AC system has become very popular nowadays and it is more often used in most of the traction systems due to several advantages such as quick availability and generation of AC that can be easily stepped up or shut down, easy controlling of AC motors, less number of substations requirement, and the presence of light overhead catenaries that transfers low currents at high voltages and so on. The supply systems of AC electrification include single and three-phase and composite systems. This is the block diagram of alternating current electrification system. It consists of rectifiers, transformers, motor control, interfaces with the motor as well as the overhead wire. It will rectify the overhead current through the transformer. It sheds through the motor. And the advantage of this system is few substations are required, lighter overhead current supply wire can be used, reduced weight of supply support structure, reduced capital cost of electrification. And coming to the disadvantages of this system, significant cost of electrification, increased maintenance cost of lines, overhead wires further limit clearance in tunnels, and upgrading needs additional cost, especially in the case of there are bridges and tunnels. The railway traction needs immune power with no cuts. And coming to the composite system, last one. These systems, trains are used to provide continuous journeys along routes that are electrified using more than one system. One way to accomplish this is by changing locomotives at the switching stations. These stations have overhead wires that can be switched from one voltage to another. Another way is to use multiple systems, locomotives that can be operated on several different voltages and current types. In Europe, it is common to use four system locomotives like 1.5 kV DC, 3 kV DC, 15 kV 6 into 2 by 3 Hz AC, and 25 kV at 50 Hz AC. Well, then, thanks for watching this. I'm Surendra, signing off. Bye bye.